All right, before we check our homework that we were working on for our chi-squared work, I would like to introduce this term. It's something on the moon. Fissures?
Popcorn.
Fissures on the moon. You don't have to write this down. Fissures on the moon means little cracks and valleys that look like veins. So from a distance, they might look kind of jagged structures like that on the moon. They have a name, and it's called rill. Rill. Sometimes, have you seen that symbol used in another setting? Read it later. Have you ever seen rill? Read it later. It's a symbol for that as well. All right. So I'll leave that up for our viewing pleasure. It'll come out to play in a minute. Joel, we're sorry you're still not with us. I hope that you are definitely going to be back with us on Monday. Get well. All right. All right, we have looked at drawing from one sample. Have you noticed that yesterday when I gave you the bag of M&Ms? It was one sample. That whole bag was one sample from one population, the M&Ms. And we're looking at categorical data. What's the difference between categorical? I'm sure there'll be a card on that one of these days. What's the difference between categorical and quantitative? Can you review that for us, Brian? What is the difference?
Categorical and quantitative. Quantitative is numbers.
Right. And categorical is?
Not numbers.
Is not numbers, like red, blue, green, brown, yellow, that sort of thing. So what we did yesterday is we were introduced to a new statistic, and it was the chi-squared statistic. And we are also introduced to its graph. And all we know, depending on the actual degrees of freedom, is that it's going to be skewed to the right. So get used to that. And as we found chi-squared values, say that similar to our z distribution, in that it went like this, but our numbers on the chi-squared start at 0, or maybe I'll do it like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you're getting a chi-squared of 10, you're not expecting a very high probability behind that. So the higher the chi-squared, the more evidence against the h sub o. All right, did you gather that in our discussion yesterday? The more, once you write that down on yesterday's work somewhere, the higher chi-squared, the more evidence against h sub o, because it's becoming more and more rare of an occurrence. The higher chi-square, the more evidence against h sub o. So in your exploration yesterday, what was your chi-squared, Kevin, with your actual M&Ms?
15.
15. That's very high. Do you see then? Maggie, what did that lead you to do?
We rejected.
All right. So, all right. Where did you go? Remind me, Maggie. Where did we go with our chi-square to find the p-value?
We presented this chart? Or
Yeah. What chart was that?
Was it B, C?
C. All right. So we're going to a new chart now, and it works very much like the B. So, Bree, could you remind me how the B and C chart work? Like you got a what? 10? What was your chi-square? 10?
15.
14.99.
Oh, yours was different. 14.99. So where do you go with that number? Explain to me how we get the p-value from the chi-square.
You find your degrees of freedom.
Right. And how do we do that?
With this situation, it's 1 minus, or the number of categories you have minus
did you
1.
Write that on your notes? I know you did it, but I want you to go back and make sure it's clear for study later. Number of categories minus 1 is your degrees of freedom. So in this case, green, everyone had the same degrees of freedom.
5.
What was it? 5.
5.
So we had 6 categories of color. Minus 1 is 5. So we went to degrees of freedom 5, and then what did we do?
And then we looked within the body of the chart for the interval that captured
Right.
our number.
Right. And what was yours?
0.01, comma 0.02.
All right. And so when you compared that to alpha, it also led you, alpha was larger, so this is rare. And that means we are going to reject H-sub-O and say that this is a possibility, that there's evidence for this. All right, Shannon, what was your number?
For my sum?
Yeah, for your stuff, yeah. Your chi-square number.
Wait,
I feel confused about this one. The number that you looked for in the body of the chart.
oh, 11.16.
11.1, yours as well?
Yeah.
Yours as
We
well?
were, yeah, you were in our group.
All right, and Maddie, what was yours?
Ours is really high. We got 23.35.
Wow, okay. You're definitely going to reject. All right. And what about yours?
12.07.
Okay. Did that lead you to reject? It sounds pretty rare.
It captured 0.05, but it was at the upper half, so it was 0.05 down. So.
Okay. Yeah, we tend to ignore the fact that it's on the end point and go with the other values. All right. Let me then define this test for you. This has a name, and it only involves when you have one sample and one sample, and you're looking at one type of category, like color. We had various colors, but only one category. It was colors. So when we do that, we do this kind of chi-squared test. You have to learn 3 chi-squared tests. You're done the first one. We're going to look over the homework, but you're pretty much done with the theory. And it has a name. Please add it. It's probably written on your note plan on the front. It's called the goodness of fit test. Goodness,
This is the test we run?
of fit.
This is what we did
Chi-squared.
yesterday?
Yep, chi-squared test. And it makes sense because we're wondering how good does our data fit what the company says. Goodness of fit test. So we're going to learn 2 more. We'll start the second one today and see how far we go. One thing I didn't tell you again yesterday was the preconditions. And that's because you didn't know enough to evaluate one of them, but now you have come up to speed. So tell me the names of the categories that we looked at yesterday. We did observations, then what? Dan, what was our next category?
Expected.
Expected, then what?
Observed minus expected.
And then?
Observed minus expected, all in parentheses squared.
Alright, and then?
Parentheses, observed minus expected, and parentheses squared, all of that over expected.
Alright. These were the values that we added up, 1, 2, 3, 4, 5, 6, to get our chi-square. So in that, I was expecting you to repeat that on the homework. And we'll see what kind of chi-squares you came up with the peanut M&Ms. However, I need to teach you something now that will be used before you start a chi-squared test, the conditions. So we're still on the goodness of fit. The conditions are not rid, they are real. All right, so real, however you can remember real. Similar to RIN. Let's go over those. A random sampling has been conducted. We're going to have one sample, so make sure it's random. Independent. If there was an SRS, then for an SRS, you would make sure that 10N is less than big N. Just like before. If it was like an experiment, and you do have a randomized experiment, but it wasn't a true random sample, then you would just discuss independence. Does the smoking habits of one person affect the smoking habits of the next? Something like that. So if ours was an SRS, we were assuming they were randomly selected when they went in the bag. And lastly, is the new one that you don't know, and that is large expected values. So that's why I had Dan tell me the names of the columns. So the expected values was right here. Can you review for me how we got those numbers again? Morgan, how did we get those expected numbers?
So, we took the percentage that the company claimed,
Like say, what was blue?
0.24.
All right, they said 24% were blue, and then what do we do with the
We
0.24?
multiplied it by the sum of
The total.
the sample. Yeah.
So did anything from this column interfere and be involved in this column then?
No.
No, so the observed amount, except for the total, I guess that was observed. So the only thing we needed to get the expected was the claim of the company and the total. And we took each percentage times the total, and that's what's expected if the company's claims were true. So that is where we're going to look. So we can't do a real check until you've gone at least this far in your chi-squared work, because the large expected values, and all I mean is n for every value in the expected value column has to be greater than or equal to 5. That's not that big, but that's the requirement. So, and you have to conduct the test, at least to this column, before you even know if you've passed the RIL.
Wait, what's n?
It's the number of the expected
She's
values.
just saying everything in this column has to be over 5.
5 or over.
Yeah.
Large expected values.
All the-
N is expected value.
All the observed counted together, or all the expected counted together?
Expected.
Expected. Okay.
Counted together or individual?
The sum of them or
No, each one.
each one?
So
Each one.
if one of them doesn't do it, then the
Right.
whole thing's gone.
Alright, I have a trick up my sleeve
Oh, let's
Oh.
see.
to show you what to do if one of them is low. We can squeak it through, but I'll do that later. Alright, so
I don't know if you.
let's look at our homework. Pull out your peanut M&Ms. Can you point me to your chi-square that you got for that?
I squared.
Magic, I looked at yours earlier. Let me see
For n
what you
to
got again. That's very close to what I got.
to be greater than 5.
What did you
expected.
Okay, Kevin? Alright,
How do you get the expected?
good. Good?
How do you get the answer?
Like,
How do you get the answer?
For this one?
Yes.
For the chi-square?
You after you count them up, you
Looks
put
like
it
you
into
did
the
all
C.
that.
Then I count them up?
Alright, no, you did all that.
Well, I did it wrong at first, Ryan. I did them
Yes, I did
together. You
And
need to
did
do them
you
separate.
See where if he's on the right
What do you
track?
mean I did the, what do you mean I did it?
Where's your chi-square?
What does that mean?
You did.
Here?
You did
Yeah, that's
it.
healthy. Where's yours? Chi-square.
I didn't
This
get
one?
that.
That's a little bit off.
I got-
Where's your
I
Okay,
did
you
that
added
and then I
these
went
up.
to
You're supposed to add these up when you're done. Get 11.35, then put it in the table. I'm not sure what you did here.
I got that one. I got that one.
Oh no, you did actually, yeah. So add this, all those up. You should get 11.35.
And that one.
I
answer is correct.
Just
No, no,
the
sorry.
rest.
Add that with this
Right.
and this and this and this and this. Add them all together.
Okay. So,
You did it
most
already,
of
you just didn't do
us
the last
are got around 11, a little higher than 11. So we're expecting that to probably be a no-go, but we have to check. So we took our 11.3. Haley, remind us again the procedure to follow with the 11.3.
Then you put it into table
That's
C.
the chi-square,
Oh.
0.025.
You go into the, you find the degrees freedom,
which in this case
is 5.
is 5 again. Okay.
Yep. And then you find that 11.37 in the body of it
And where did it show up?
at 0.025.05.
Okay, very good. So that led us to do what then, Haley?
That led us to a reject H of O.
Okay, so we reject H of O. There's enough evidence to say the company's claim is incorrect. At least one must be wrong. Maybe more. All right, let me show you how to find chi-squared on your calculator. Like if you don't like going between two columns, it's kind of ambiguous sometimes, especially when 0.05 is on one of the ends or the other. So let's go to second vars. So we're going to go to second vars, second variables. And that will lead us to a screen that we're going to go down to number 8. and it'll say chi-squared CDF, and it'll ask for values or give you a parentheses, and the first value is the chi-squared number, 11.37. So they're going to ask you for the lowest number and the highest number. So what we want is the probability after this. So if this was 11.35, it's the lowest number.
How?
What's the highest number? Is that any different?
Mine is number 7.
Yeah, mine is too.
Really?
Wait, let me check.
Anyone else is on mine?
What
Is
is it,
number 8?
second bar?
Was it supposed to be?
Wait, what is
Yeah.
that? Where are we getting-
Chi-squared CDF? Is
Yeah.
that not
Yeah,
number
mine's
8?
8. But we have a different calculator.
Yeah, okay,
What
so
is-
7 or 8,
Dan,
make
yours
sure
is
it's
7.
Is
CDF.
number 11 relevant?
Pardon?
What is the relevance of the number 11?
That was our
It's
chi-square.
11.37, not 11.
Oh, I thought that was 1137.
11.37. So, or 11.35, I saw numbers around that as I walked around. So here, the calculator will want the lowest number, and that's this one, because we want to get the area here. What's the highest number?
Is it? I would say 1 minus, but that doesn't make sense.
No, it's like 100 or 1,000. I don't think it'll take a
Oh,
million.
we just have to
I'll put in
It's 100.
1,000 just to see. It might not take it. 100 would be plenty.
Nope, it didn't take it.
It wouldn't.
Kevin says it was 100.
100. There's the last number on chart. says
5
100.
is the degrees of freedom. So this is the highest number we've done this
Yeah, it took it.
with. And this is, it took 1,000?
Yep.
I didn't
Morgan
try
said it
1,000.
didn't.
Well, I didn't put in the last
She
number.
just
Oh,
put it
okay,
on
mine
at
took
1,000.
1,000.
Okay.
I
All
did
right,
100.
so
1,000.
Morgan, what comes out on the calculator when we do that?
0.044.
Uh-huh.
Yes.
All right, and we said it was going to be between what two numbers, Haley?
0.025 and 0.05.
All right, so
Barely.
0.044 did fall into that range. Okay. All right, so that gives you a little more precise number to work with if you want to do it on your calculator. You might want to write down those steps, yes.
Do you think that one day before the AP we could just have like a calculator day and review all the calculator things?
There's a list in the back of the book, we can
Oh,
go
really?
over it. Yeah.
Yeah, that would be
Wait, so
helpful.
this
Alright.
gives us
All right, well,
a more precise number.
yeah.
So we still reject it.
Yeah.
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 It's never going to be out of our range if we've done it right. So, but like sometimes 0.05 is on one side or the other, and we don't know whether to reject it or not. So this we won't have any questions. Okay, let us do one more. Do the birthday problem. Turn over to the next problem, and you can start setting that up. We're going to do a chi-squared test. How does it work? A test for equal proportions or birthdays evenly distributed across days of the week. So then we're going to look at a sample of 140 birthdays. So let's start doing a real. We won't be able to do the L part. So did it mention randomness in this selection?
The random
Yes.
sample.
Yes.
Yes. Wait, why won't we be able to do L?
Because we haven't
Oh, we have to do it
calculated them
first.
yet.
Alright, I thought you meant like at all, sorry.
Independent,
10 times
Probably.
each of one of those is
Yeah.
more than the amount of Saturdays that exist.
well, the amount of births.
Oh, okay.
More than.
It's
The
a
amount of
family
birthdays that
of
are on that
births.
day, so yes.
So independence is good. 10 times
Yeah.
140.
It's not an
that's-
SRS, so
It's not?
no.
Then, yeah.
What
It
is
says it's the
it?
random.
Random
Yeah.
sample.
Yeah, that's what it
That's
is.
what an
Yeah,
SRS is.
That's what an SRS
it's-
is.
Well,
Okay.
also,
It would
so
say
it's-
SRS.
No, sometimes it just says random.
Sometimes, yeah, it just says
That's
one.
fine.
And that's
Simple
why-
just means it's not stratified or
Here's what I'm saying.
what's the other word?
There
Clustered.
there was a time when
So
no one was
it's
born.
fine. So
People were at
then,
birth.
large expected values. So start your chart. We've got the basics. Observations are given. Then you're going to calculate your expected
You
values.
remember
So, can you talk us through that, Maddie?
Maddie?
What are we expecting? They didn't give us a percentage, but they expected the days to be the same. So what would be the percent of births on each day?
So it'd be like
Anyone come up with that number?
Is it like
0.14?
Which is
1 out of 7.
1/7. Do you see that, Maddie?
yeah.
We're expecting, if they're going to be the same every day, we're expecting 1/7 on each day. And Haley said 1/7 is 0.1. 0.14.
So like
Alright,
for Sunday
so-
you do 0.14 times 13.
We're gonna do not 13, but
The number
the
of
total number
The
of
total
births,
number of
just
all
like
the
when we did the M&Ms. We
140.
all right. So how will that be any different the next day?
It won't be.
All right. So this will be easy.
That's
All right. So what is
That's how the colors
0.14 times 140?
The M&M.
19.6.
Okay. So that's going to be the same on every day.
Every day. The other half of the baby
So-
was born to the next.
So the percentage we're multiplying each day is 0.14.
Right.
Okay.
Because that's a seventh.
Right.
So if there's no difference on any day, we're expecting a seventh of the births to be on each day. So, how's it doing then? What was that number? I missed it again.
19.6.
19.6.
90.7.
19.
Gabrielle. 50 minutes.
I never say 50.
You say Rob.
He said Rob. I never said 50.
1-5.
Right, he wasn't Chinese. 1-5.
I didn't say it like he was Chinese.
You definitely said
All right.
1-5.
So, did we pass real? Is the L okay?
Yeah.
Or looking under our expected values, they were all 19.6. So that is 5 or greater.
Sunday the first
So
of
we
the week.
checked off the real. So now I need a hypothesis. So what would be a good hypothesis for this experiment? Do you have one in mind? Let's see. Dan, what would be a good null hypothesis for this?
That
Rob would be negative. Nope, never mind.
Boy.
Not exactly the claims of the company this
Yeah,
time.
no company making babies.
How about this? Birthdays are,
Evenly distributed.
right, birthdays are equal,
Question.
evenly distributed, or equal in proportion for each day. Birthdays are evenly distributed among the days of the week. We're trying to say it's the same number all across. Ages of A. So Dan, what will we say about that one?
Birthdays are not
all right.
evenly distributed
Alright.
among the days.
All right. I think you got the idea.
Did
Are
we?
not blah blah blah. I'm going to be lazy. Okay.
Wait, Miss Powell. It's gonna fail L.
No,
Look
it's
at all
not.
the L's were
Oh, it's
19.6.
expected. It's expected. Never mind. Sorry, I thought I was looking at the wrong thing.
Okay.
All right. So, what kind of numbers are you coming up with? That I just tell. I'll jump to these. Anyone to this column?
Yeah.
What do you
no,
got?
not there.
We'll check
Squared,
you.
no, no.
Which one?
She's way ahead.
I got 2.22.
Okay. Next.
I got that as well.
0.59. 0.99. 0.008.
I'll just put 0. I will put 0 for that one. All right. Keep going.
2.79
And
0.13
Today, Mark
and
said-
1.07.
Play some b-ball. and I was like,
anybody
I'm gonna
vastly
say that.
different from those numbers?
I got
I-
the exact same.
I still have to do a lot of math. And
All
I'm
right, you
not
can
gonna
jump
look stuff
ahead
down
and
here.
borrow her numbers. If anyone got, has anyone got that far that can confirm them?
I can confirm them.
Okay, all right. Let's just go with these numbers. We all know how to get the numbers. So what did they sum up to, Morgan?
I didn't do that.
Morgan.
7.79.
All right, so that's a reasonable number, 7.79. So that's our chi-squared statistic. So what are the degrees of freedom this time?
6.
Right, 7 categories. One category is days of the week, but of those, broken into 7 different individual categories in a category. So 7 minus 6. Then we have degrees of freedom 6.
Wait, 7
We're
point.
working with a chi-square of 7.79.
It's gonna be less. It's gonna be less than 0.25. Wait a minute. What?
What?
Wrong chart.
You can't. The first one for the
Less
row
than
6.
0.25.
Oh yeah.
Because the
Okay,
first one
that's
in row 6
Greater
is
than
7.
or less than?
Less than.
Are they getting smaller?
Yeah, because the first one in the 6th
Let me-
row
let me
is
peek at it.
7.84.
All right, so it's going to be less than.
Right.
Well, these are getting bigger, right?
Right.
Less than 0.25.
So how do you know what the
I
other
hate when
number
that
is, though?
happens.
All of them added together is 1.07.
7.79.
Oh.
See?
What is the 1.07?
That's her 7th one. That was her Saturday or
I
something.
did it in the calculator and I got 0.25.
0.25?
Yeah.
All right, so that's weird. Okay, 0.25.
Yeah.
All right, we got less than 0.25.
So we
The
just-
calculator gave us 0.25, but either way, what shall we do? What shall we do?
So we don't have another number for this. We just know
Yeah.
that it's less than 0.25.
Yeah,
I
that's
got-
enough. That's
Okay.
enough.
I got a slightly different number than Morgan did.
Right here.
Yeah, I got 7.82.
Okay,
Well,
that's
it should be the
okay.
same answer though.
Okay.
It's just a couple hundreds off or different. Not that yours is off, but we got the gist. So
Yours is wrong,
therefore,
but
we're
Morgan's is
comparing 0.25 or numbers below 0.25. The calculator actually gave us 0.25. We're comparing that to 0.05. And that is but it's higher. So therefore, that's not that rare. So we could see that was coming. So about right there, it's not that rare. So therefore, we fail to reject. So when we fail to reject that, we say there is not enough evidence to say this.
Number is lower than
Oh wait, yeah. Oh, this is gonna throw me off.
Yeah, that's why we went to the calculator.
0.05 is in that number.
Yeah, but
This is gonna throw me off.
all we have to do, all I can say, if the chart won't help you, you'll have to go to
No, it's
the.
not. Wait, I don't
So this would say that there's
That's
not
greater.
evidence.
Huh?
This would say that there's not evidence.
If you reject this, you say there is not enough evidence. I mean, if you fail to
Yeah,
reject
fail to reject, there's
it,
not enough evidence.
There's not enough evidence to say birthdays
Why
are
not?
not evenly distributed.
If alpha
So
is
that's saying they
0.05,
are.
that's within that bound.
0.05,
the
this is way higher than
But
0.05.
it's less than. 0.05
Yeah,
is.
well, we don't know
We usually
from the
just
chart, so we grabbed it from the
0.25 is
calculator.
we usually just
So
take
it was
the number that we're
0.25.
given.
So
Like, we
compare
know-
0.25
we know
is
it's a-
greater than alpha.
Yeah.
We know
So-
when it's an interval
So
that it'll be in
the
there.
chart kind of let
When
us
it's
down
open-ended,
because
we
it
have to
dropped.
just take the number, 'cause
It
that's the only
dropped
thing
it
we can
off,
really
but you
do.
can see
It's
from
nowhere
here
near
that you were gonna
0.05,
expect it to be.
That's not what we're saying.
So if we
fail to
rejected
reject.
it, it would have to
interval is
be
greater.
less than 0.05.
Right.
The interval is open-ended.
So normally
Yeah, but it's-
normally when it's greater than the interval, we fail to reject. When it's greater than 0.05 without an
So
interval.
we're not necessarily talking about an interval this time. It's
You know,
just
this
like,
is just
It is an
normal
interval, though.
stuff. We've been doing tests. This is the
Okay.
third chapter now.
Right,
We've
this
been
is-
doing tests, so it's no different.
Okay.
When P is greater than alpha,
Mhm.
that's when we fail to reject it. If P is way little, the probability is so small that this is true, we're going to reject it. This was not way small. It was bigger than alpha, and we fail to reject. So therefore, we say there's not enough
The boys gonna
evidence
need
to
some
say
review before
birthdays
AP.
are not evenly distributed
Season
across
before
the
review.
days of the week. However, guess what?
Wait.
Guess what? We have committed, if we fail to reject, one of the possibilities, only one when you fail to reject, we have made a type 2 error, because guess what? They are different.
Yeah.
Type 2 errors has
No.
been made. There's a chance of us doing all the math right
I'm still doing
and
it.
getting an error, and that this is the case because actually births are not evenly distributed. There's a lot less
How
on
would they?
Saturday and Sunday because nobody will schedule a C-section. No doctor will come in on Saturday and Sunday and schedule a birth. So there's a lot less on Saturday and Sunday. So
That's weird.
we did make a type 2 error, but you wouldn't know that from our work. Okay.
It's a weird thing to like.
All right,
schedule
that's the
the-
goodness of fit test.
Well,
And
remove this from the
I am going to begin teaching you the next test. See how close we can get to the next kind of
So I could have been
test.
born on the Thursday.
Hi, we are.
Yeah, we know what day of the week we were born, don't we?
Your baby's coming up, right? Yeah, I'll be there. Like one, right? Yeah.
All right, so part of your assignment so far is to cut out your cards. Cut out your cards. And I want you to study the cards from both days. So we're up to 20 cards. So we went over the 10 today, so that should help. So I can ask you one of the 20 cards, so that's part of your assignment. We're preparing for the final
Except for the
and the
ISO.
AP test. All right, the more we do now, the better.
Are we gonna learn the LSRL ones?
Not today. All right, so those are still out of the mix. So didn't I have 3 on the floor?
Yeah, there was 3.
Okay, those 3 are still out of the mix. All right. So far, the first test that we have learned is the goodness of fit test. So we're going to put that down and pick up another test. What we're going to have going on this time is we're going to have more than one sample and more than one characteristic. So we are going to get fancy. So once again, so we can take a note of that. So, all right, for more than one sample, and more than one characteristic. In this case, we cannot use the goodness of fit chi-squared test. We have to pull out another chi-squared test. And the next chi-squared test is the chi-squared test for homogeneity. Nice word, huh?
Oh yeah. I thought he was there.
Then we're going to look at the chi-squared test for homogeneity. You have to pick a nice word, don't they? We will still use real. We still have to check real. But I have to teach you how to do that in this case. A lot of times our information, when you have more than one category and more than one population going, most of the time we put the data in a two-way chart. So we did two-way charts starting on page 14. So we're ready for two-way charts again. So we're going to look at a two-way table, and I'm just going to teach this with an example. So would you read, Kevin, the background to the two-way table that I have there before you?
I have a quick question. Did you say real is going to be the same?
Yeah. No, she doesn't teach it.
It's going to be the same, but coming up with L, you don't know quite how to do that with a two-way chart, which is more than one category and more than one population.
RI is the same though?
Yeah, R and I are the same.
Are they always this? Did they ever change?
RI is not resistant.
Okay, Kevin?
Market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a supermarket compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of bottles of French, Italian, and other wine purchased. Here is the table that summarizes the data.
All right, so we're going to go to the liquor store or the grocery store or something, and there's going to be music playing or not. So let's say the music is no music is one choice. We have French music, and we have Italian music.
When I hear French music, I buy 1 bottle of Italian wine.
Okay, so that's the music, and over here, this is the type of wine. It could be other, Italian, or French. Alright.
Nothing makes me want to get out of the store.
Or the sugar sibling wine.
So, how many entries will I have? I have 3 characteristics of music. Okay. So they are. So, Shannon, would you describe for me what the 43 means?
Any other type of wine.
Like I'll go all the
That
time.
you buy when there's no music.
Yeah, right, no music. Okay, Bree, tell me what the 1 stands for.
The 1 stands for the French wine, the French music.
Right. No.
No.
Is it not in the Italian wine category?
It's in Italian and French.
So it's
So this is
French music,
this
Italian
is
wine.
music, and this is wine.
Yeah.
So this 1 stands for what?
The French music, Italian wine.
Right, so how many bottles, when French music was playing, how many bottles of Italian wine were bought?
1.
Okay, so you tell me, Maddie, what does 19 mean?
This 19 is the number
These are all.
of bottles of wine purchased.
All right, what kind and what was going on musically?
Italian wine, while Italian music.
Right, all right, so Maddie, you tell me what this 11 means.
That is the number of Italian bottles of wine purchased when there is no music.
All right, you get the idea what this chart is saying?
Yeah.
All right, onward then. All right, we'll start with an hypothesis. So hypotheses.
Not even like a rewrite.
H sub O, there's no difference in the distribution of wines purchased in stores with no Italian and French music playing. So it doesn't matter what kind of music you're playing, it does not affect, it's hard to write it all, but it doesn't affect the distribution of wines purchased.
Could we just say music does not affect wine purchases?
I think you can. H sub A. I have to look at that. There is a difference, ...
Wait, what is no IT?
No, comma, Italian, comma.
Oh.
There's no difference in the distribution of wines purchased in stores with no Italian and French music playing. And over here, the alternative hypothesis, there is a difference in the distributions of wines purchased in stores with no Italian and French music playing. The hardest part, which I hope I can get over right now, is how to come up with the expected value. So we have observed, and we have a whole bunch. I'm not going to do a chart like we saw with the peanut M&M.
Okay.
I'm just going to I'm going to erase H sub A. You know what it is. So I have some room here. All right, so I'm just going to put my expected values over here. So I still have none French and Italian. And I still have, so this is music. It's kind of confusing because you got music and wine on the same names. So they like to keep us thinking. All right, so I'm going to do the expected values over here. Can you stay until I get them done? Can you stay?
Yes.
Till I get this done? All right, it won't take that long. All right, so over here I need the totals here. So these come out to 99. You can borrow from mine.
It's already on our paper.
31. Okay, that's no fun. 113. Down here we have 84, 75, 84. 75 and 84. Do I have the right numbers?
Yep.
Matching totals. All right. If you don't get this, I'll give you a way to do it without understanding it, which I don't prefer. So, to find the expected value of French bottles of wine sold when no music is playing, I want the expected value. Notice, if music doesn't matter at all, then how many bottles total of French wine were sold?
I'm sorry.
99 out of, whoops.
None.
I need this
None.
number.
243.
Thank you. So, I'm going to grab that 99 out of 243. That is a percentage or a fraction. That should hold true if music doesn't matter at all. and I know that all of the French wine divided by all of the total wine is this fraction, then I should multiply that number to find out how many French nuns there were. I should multiply that number, that proportion should hold. I should multiply that number times the total of 84 to get the percentage expected if music didn't matter at all.
I
So,
got 0.34.
so is this number divided by this number times this number?
It's 0.34.
0.34?
Yeah.
Okay. That'd be nice to gather in a clearer chart. 0.34. All right. So let's try it again for the next cell. So over here, we're still in French wine. So we're still expecting 99 out of 243. But now we're in French music, so we're expecting to multiply that by its total.
30.56.
What was the first one?
0.34.
It's not that, it shouldn't be that different.
Yeah.
I got 34.
34.22?
Yeah.
All right, we're going to go two
Okay, I guess I can do
decimals. All right, the next one. We're going to take, we're still in French wine, music doesn't matter, so 99 out of 243 should hold true no matter what music's playing. So 99 out of 243 times
84.
84,
34.22 again.
34.22.
Yeah, it's the same math as the first one.
34 point, you're right. Okay. All right, in like manner, can you finish the chart? You can do this one again. So now I'm going to go to Italian nun. So this time, if music doesn't matter, we know Italian wines, 31 out of 243.
I was picturing an Italian nun.
Should hold true. And since we're now doing French, we're going to grab this total, 75.
That is 9.57.
10.7.
Wait, why are we doing 75 in the first column? Shouldn't we do
9.5?
84?
Do 84 in the first
Yeah.
column.
9.57. What's that? Am I in the wrong one?
Yeah.
Yeah,
I'm
you're in the
sorry.
wrong column.
Okay. There we are. So I missed one. So this one,
That is 9.57.
all right, and that one was 31 out of 243
Times 75.
times 75. So, in like manner, I have all the answers. 10.72, 39.06, 34.88, and 10.72 and 39.06. Does it pass real?
Yes.
Are all the
Yes.
expected values, and each one of them 5 or greater.
Yes.
All right. Now, this would become a big pain to put in your calculator because you would have to do this value minus this one, quantity squared, divided by this one, added to this value minus this one, quantity squared, divided by this one, and you have to do that 9 times. So we don't recommend doing it by hand because it's
So
easy
we
to
should
make
use
a
the
mistake.
calculator.
Yeah, you don't know how to do that yet.
Oh, right.
So I will bring that up on Monday. So your homework is to study these 20 cards, and I'm going to continue to write down who was able to get their card.
Yes, ma'am.
So you,
Is that graded?
if there's one, minimally.
Okay.
All right. So get your cards, and we will finish our test for homogeneity
Mister,
on Monday.
can you take a picture of that and send it to me?